Oh, okay. Probably just doing something. It looks like one of your, I'm really bad with pronouncing really interesting names. So, something that comes with Arch prepared the best. They have the pizza.
I think Anchorage is getting food too. Maybe just waiting on Jeff.
Okay.
Wow, this is one of is like a good turnout, but it feels like not such a good turnout in this room. We got pizza.
We have better pizza than you.
This is here. I see.
Conroy, did you get this? Whoa, wait, you're in Anchorage.
Are you a hologram?
Power of teleportation. Do we have the webcam here working?
It did briefly.
It's that one pointed this way. I can't get that one pointing that way. Oh, I can help with that. Sounds just no way with that one. a Slack channel called Leadership 2020. And so you can just hop in that, and that's like your direct channel to get in touch with anybody who's directly organizing the Developers Alliance. So yeah, our meetup planner for 2020 is going to be Bradley. Tonight's speaker I met while I was traveling in New Zealand. This is a funny chain of events, but I'll give you like the whole outside view because I think this is really interesting. But I was introduced to Bill Kennedy from some really passionate Go programmers, Lee and Lucas Brown. And I flew down to Miami to take his course. A year and a half later, he invited me to speak at GopherCon in Australia. So I flew there. I met somebody who had seen our logo that I asked on the Gopher Slack if they would design for us. And it turned out that somebody in New Zealand had also asked the same designer to design them a Gopher logo. And so we both showed up wearing our Gopher logo shirts for our specific location. So he had a Kiwi and we had the big Gopher and the Yeti costume. And it turned out he worked at Vend. And Vend is where I met Kat. And so I was talking to her a bit about, you know, kind of what we're doing up here. And she thought it was really cool and appreciated our talk and wanted to reciprocate and asked what she could talk on. And it turned out that she was a QA, a lead QA person, engineer. I don't know what your official title is, I apologize, but over at Vend. And that's something that I, as a developer, feel like I'm always kind of not sure, you know, should I be doing behavior-driven development or test-driven development? And how does that work in the CI/CD pipeline? And then who's doing QA on the end of that, right? Because I'm normally the one doing kind of everything. So I brought Kat in to help give us a perspective and an introduction into what that looks like at scale. So Kat, thank you for being here and taking your time to present to us tonight. And I'll turn it over to you.
Awesome. Can you see my screen?
Yes.
This meeting is being recorded.
Perfect. So, hi, welcome everyone. Huge thanks for turning up and a huge thanks to Jeff who made this possible. Just like it would be about 10 years ago, it would be something really unheard of. Just to think that I will be sitting here in Auckland and presenting to Alaska. That's something really, really crazy, and I love this type of thing. Now, today I want to talk to you about the new challenge that we face today, continuous deployment, and how we can not only survive, but thrive in it. So does any one of you recognize this photo?
Falcon 9.
Yes, that's the test one that failed. So it's an awesome proof of a challenging human mind that is able to read the stars once it's set in it. But how? Welcome to the Mindshift. So a few words about me. I've been working in software testing for more than 15 years, starting from a complete newbie. I'm an ex-uni teacher and growing into a QA test manager, test lead, covering a variety of domains from medical software and accounting to power data management. And I'm also a keen trainer as I love sharing my knowledge with others and learning from them. However, let's start understanding what continuous deployment. So when I was preparing for the speech, I was looking for something that could illustrate the very idea of the continuous deployment in a very straightforward and vivid manner. And I found just the perfect one, thanks to staff.co.nz, that's New Zealand news agency. And just this video, I'll just try to do the sound because we don't need it. So this video displays a stunning exhibition at the Whangarei town basin. It's called the Whangarei ball clock about time. It is a quite complex machine. Each ball represents 15 seconds. And 1/4 have collected, one drops to the minutes section, and the other 3 return to the bottom of the track. Seconds combine to minutes, minutes into hours. But the most amazing part that it requires absolutely no human interference. Everything is completely automated. Once a ball has left its initial state, it goes through an intricate labyrinth of pathways right to where it should be. The team of 7 volunteers was a mix of engineering and design background, needed 8 years to plan and build the Swan. What a perfect illustration of continuous deployment process. Once a piece of code is committed, it goes through the pipeline through various tests and stages, and when all of them give a green light, it finally lands in production. Only human action was to commit a particular piece of code. And yes, building a pipeline requires a solid amount of time, effort, and knowledge. Now, let's take a look at what we're dealing with. What? First of all, it's a completely different process. Okay. Shouldn't be. So, do you know the difference between continuous integration, continuous deployment, and continuous delivery? Let's refresh it a bit. So, continuous integration, also called CI, is a process of committing small chunks of code into some common repository several times a day. Each commit is tested for bugs using some automated suite, and if there is a bug, it's really easy to undo these changes and get back to the working flow. Automation is a big part of continuous integration and gives you and your team the confidence to deploy the new stuff into production. Continuous delivery, it's the next stage after continuous integration. So sometimes it's referred as to CD. Continuous delivery is a process of keeping your code in a state of readiness. So actually, with continuous delivery, you can, at any time, you can click the button and the code is delivered to production. So this gives you and your team options. You can release a new feature right away, or you can wait until the other features are ready and release them to production. But the key is you still press the button to release the code in production. And continuous deployment is a complete game changer because with complete, it automates the deployment process. So once you push the commit button, in our case, it's merge to master, there is absolutely nothing, well, except for tests, to stop your code from going into production. So continuous deployment removes a manual step from the build and deploy process. So just the very important thing that I want you to remember in continuous deployment, once you clicked commit to master or merge to master, there is nothing stopping you from deploying it to production. And this is very different to the old process where developers could go without merging their code anywhere for weeks or even months. So with the old way, the deployment of the code was a big event. With continuous deployment, it's very quick. So the main feature is short deployment time. Depending on the pipeline, the code may be in production in 30 minutes, 2 hours, depends. It depends on what tests you have and what your pipeline is. In our case, on the project that I'm working in my, just like we're trying to reduce the amount of time to say 15 minutes. Another thing is that to be successful in continuous deployment, the change that you deploy should be very, very small because you no longer have the luxury of deploying big chunks of the product. The next important thing is that while rollbacks are kind of possible, but not always, sometimes you have no opportunity to roll back to the previous version because, for example, it was a database migration and you have a farm, a cloud-based farm where you have stuff running, databases running in clusters and stuff, and it's way easier to deploy a fix rather than roll back. But in our case, sometimes we can roll back our features, and we even automated this using Slack and a special bot. So from that, you can say that we roll back kind of often, right? but it's better not to do this. Another important thing that allows you to deploy into production confidently is a feature switch or feature flag. Have any one of you heard of what it is? Hello? Okay. So I still suppose you hear me. So the feature switch or the feature flag is some feature that allows only certain people to have access to the code. So the code is deployed in the production, but no one can access it if the value is false. And you can turn it on for particular group of users, say testers or beta testers for beta users, or your whole local company. So to use your whole team as alpha testers. And also feature switch helps greatly in deploying the feature in production. That's how we do it. Say, okay, we tested the feature behind the feature flag. We think everything is fine, but we can't test it on our limited production environments. So we decide to put the feature flag at 5%. So 5% of our customers randomly receive this feature. It's enabled for them. And that's how we can quickly react if something goes wrong. We kind of turn the feature flag back off and fix the problem. So if 5% are fine, we increase to 10%. If 10% are fine, we increase them to 25%, 50, and so on. After the presentation, I will send Jeff a document with some useful links, and I will have there some information on the feature flags as well. Another thing that you need for good continuous CI/CD is a very robust pipeline. So that's how usually a pipeline looks like. And also continuous deployments means that it has different releases and deadlines. So technically, each code commit is a small release. So you can assign an official release date to promote it to your customers, but what does it mean? It means that the feature flag will be turned off completely for everyone. So turned on completely, sorry, for everyone, and all the users will get access to this feature. And another very important thing that especially you developers need to keep in mind is that continuous deployment has a completely different type of ownership, because nothing protects you from deploying bugs into production except for your pipeline. So when you are pushing this button, commit to production or just merge, it means that you are 100% sure, you should be 100% sure that the code that you are deploying to production will not break anything. Because you need to be 100% aware of the fact that whatever you committed at the moment, it will be in the production in 30 minutes, 2 hours, but it will be in production as soon as your pipeline gives you the green light. And it's something that many people are struggling with. They are still used to the old ways of doing things, when testers spent some time testing the stuff, and only after this, the decision to deploy the production was made. Now the decision is yours and nobody else's. And it also means there is no human interaction. Everything is automated. We will talk about what kind of tests we have in the CI/CD pipeline a bit later, and I will give you some advice on this. And a very, very, very important thing is that continuous integration, continuous deployment requires team collaboration, most of it, because you help each other. I will talk to you about a bit later about how testing changes in CI/CD thing, but the idea is that team collaboration is really crucial for CI/CD. Because if you deploy the bug, you don't need to find the scapegoat. You need to fix the stuff quickly, and sometimes it can be in the middle of the night, so you need to have some people on call. Therefore, you need to write your code in a certain manner so anyone could just like find the problem and fix it, or at least turn the feature flag off that causes problem. And so, as I promised, to tell you how testing is different in continuous deployment. So, first of all, testing now converts into preventing defects rather than reacting on them. So rather than finding the bugs, we are trying to prevent them from happening by testing the stuff from the stage of an idea. So when in our team, when the designers make the workflow, we sit with them and say, hey, guys, these things won't work, or we will have these problems. When we have the technical discussions, when we discuss the architecture, testers are there as well. Because we tend to have a bigger picture in mind, and we remember that, oh, okay, if you're making this API call or you're changing this thing, it may affect this, this, and this. So probably you'd better collaborate with these teams to make sure that their stuff doesn't break. Then we shift more towards quality assurance rather than quality control. So we are trying to improve the processes. We are trying to again, prevent defects from happening rather than detect them at the later stages. And we do more testing on the development environment, because it's absolutely okay for me. So if somebody has released a new bug fix or a new feature, I can download their local branch, build it, and try and test it and apply it on my test environment. Or just try to build it on our test environment and see how it works there. And it's absolutely fine. There's nothing bad that you might not have a dedicated test environment, because right now we are struggling with it. And it's absolutely fine. It's not ideal, but you can live with that. And another thing is that with continuous deployment, more testing is done by developers, because quality assurance people, they become a very scarce resource. Because if you remember, the decision about whether you need to deploy to production is made not by testers, but by you, right? Not by quality assurance people. And quality assurance quality assurance specialists are quite expensive, to be honest, and they are they are very developed engineers that can do different tasks, that can and their time is very valuable, and usually you have a very limited number of quality assurance people. And you need to, if you want your code to be tested by someone, you need to involve the someone proactively, and you need to test yourself. Also, as I already said, that continuous deployment implies testing in production, actually quite a lot testing in production sometimes. How? With everything that we know about continuous deployment, but most and first about the feature switch. Using the feature switch allows you to test in production. But unfortunately, not everything can be covered by the feature switch. And it's A and B. Feature switch might not be implemented correctly as well. So you need to test how well your feature switch works, how well it turns on and off the feature. And testers also shift the attention. They shift the attention from finding anything to finding the most important bugs first. And a very important thing for everyone, but I think especially for developers, is to overcome your fears. Oh no, code cannot be released in production without anyone testing it, without somebody approving it. No, nobody approves your code being deployed into production. The only final approver is you. So, all this means that old ways no longer work. Why? Well, first of all, time is crucial, because we need to deploy fast. We can't we don't have the luxury of waiting for a year to deliver something, some new feature. Second, the old gateways no longer exist. Again, nobody makes a decision to release into production except for you. So every small change is released directly to production. There is no project manager. There is no business analyst. There is no product owner. There is no QA who serves as a gateway. The only final gateway is you. And people have higher expectations because we need to be better specialists to do all this, to deliver quality code, to deliver it faster. So it means we already spoke that the testers should change. Should the developers change? Absolutely. So now let's see how the developers could change their attitude, how they could shift their mindset to achieve this. So first of all, you need to change the attitude, which means that you need to shift perspective a bit. You need to shift your perspective and see a bit bigger picture. So you need to remember that you need to deploy small chunks that fit into the bigger picture and fit well. Second, again, collaborate and build trust, because I can't just express how important team collaboration and team trust is, because everybody trusts you that you are a professional, and it means that nobody will check upon you if you deliver the right code or if you deliver the shitty code. That's very crucial. Another thing is it's very important to set up your goals and check them from time to time. Are we achieving what we want to achieve? So how we did this in our team. So we run 6-week sprints, and every week we get together and assess if what we have done and if we are delivering what we're supposed to be delivered. Are we on track? And if not, why, and what should we do to be back on track? Sometimes we can descope stuff, or sometimes we could just we say just it's too big, let's move it further, so let's split it, or let's just wait until the right time comes if we see that there is some big blocker. So another thing is that you need to be proactive rather than reactive. We need to be to participate in delivering the best value to the end users quicker and reliably. We need to pick up the tasks that will bring most of the value and deliver them in short iterations, nicely slicing the big chunks in small manageable pieces. And we can do this because we collaborate and we have the trust of our team. And another important thing that we need to embrace, again, the full responsibility for what we do and what we do not do. Most likely, no one will tell you anymore what you should do. You need to choose tasks by yourselves, and these tasks should add up to the team's success. Remember, with great power comes great responsibility. And to do this, we need to T-shape. So I gave you an example of T-shape for a tester, but I can kind of explain what it means to T-shape for a developer. A T-shape for a tester means that our main specialty is testing, but we also look a bit on the side of the business analysis, product ownership, development to understand better what's happening so we can develop better tests. But the very same thing is applicable to developers as well. You can T-shape as well. You can have a broader vision on everything. You can know not only your functionality, but it's very good to know the functionalities that either your functionality depends on or what you depend, if you depend on them. It's good to, for example, to know not only front end, but also at least how the backend functions if you are a front end developer and vice versa. But still, you can just learn from the support how to troubleshoot and stuff. But at the core, you still should stay the developer that you are. And, of course, make mistakes. Allow yourself make mistakes and allow the others to make mistakes. Learn from them. That's exactly how you learn, by making mistakes and doing it differently and better next time. Everyone makes mistakes. You, your colleagues, your boss, even me. I'm not ideal. I'm human as all of you. And actually, it's normal. It's normal to make mistakes. And if you have the trust of your team, it's not scary to make mistakes, because you know that you have your teammates' shoulders to support you if you fall. And that's really awesome. Why it's awesome? Because if you are not afraid, you deliver the better results. You are more open, you are more creative, because your mind is not in shackles. Oh, what if I do wrong? And you are not trying to cover your ass. And another thing, we need to improve our effectiveness. Remember, in continuous deployment, the demands to everyone are way higher. So you need to know what to deliver, and you need to make sure that everyone understands what exactly to be delivered, and they should agree that that's the thing we want to deliver. So how many times I saw that different team members have completely different views on the particular thing that should be delivered. So, and it ended up in complete disaster, because the requirements said one thing, the developer developed the another thing, the tester understood the third thing, but the end user didn't want any of that. And to make sure, so, okay, even if we are on the same ground of what we want to deliver, we need to make sure that we are solving the problem that the end user has, and that the end user can solve this problem using your software. Because, I don't know, it is possible to use, say, Adobe Photoshop for making screenshots on your laptop, but is it worth the effort? You also need to test your own code before it goes before anyone sees the outcome, especially if you have no testers. You don't want to be in a position of shipping an issue for the primary browser that could have been discovered by just simply opening this bloody browser. So how many times? Okay, I worked in companies that were running big projects for corporate users, and corporate users most likely mean Internet Explorer. And just like I was sick and tired of mentioning to the developers, okay, you've developed the feature, just open the bloody Internet Explorer and make sure that it doesn't crash there. As simple as that. So, useful tips on testing your own code. Ask the what ifs. What happens if the user does this? Or what happens if I receive the wrong response from the API that I'm calling? What happens if I send the wrong request? Run all the possible scenarios that you've thought of. And yes, do manual testing. I will talk about a bit later as well. Think about the end users, please. Because how are they going to use your product? So if your Nana was to use this product, how easy for her would be to figure out what's going on, how she can solve this problem? Stop being a perfectionist. With the current pace, in 1 or 2 years, your code, your technology will be completely obsolete. And please do not overthink. Overthinking means that, okay, I'm writing the code, but what if in 5 years we will try to mount this code on the International Space Station? Do not do this, please. Because in 5 years' time, everything will be completely different and you just wasted your time. You need to ship the good enough code that is maintainable, that is stable, that does what it's supposed to do. It must not be perfect, because nothing is perfect. Avoid gold plating. It's related to the previous two. So do not deliver small improvements when the end user doesn't need them, because they always come unnoticed, and just like, why did you spend this effort if nobody notices this and if it brings no value for anyone, not for the user, not for you? Another thing is write stable code. And I will share with you some more tips on how to write stable code. But you need to remember that you need to deliver in small chunks, because small chunks is easier to fix and review. And you need to write maintainable code. So several years ago, I had a really nice advice that made me laugh. But anyway, write your code as if the guy who maintains it is a maniac with a machete who knows where you live. So when you are writing the code, you are not writing the code for the computer. You are people. You are writing the code for people who will be using your software. And this code will be maintained by people as well. It will be support, it will be your fellow colleagues, developers. But we are not writing the code for the computers. We are writing the code for humans. So you need to write it understandable. And understandable code means maintainable. And maintainable code means that it's more stable. Because I had an experience once in my life when a guy, we were developing software for primary stock market for the largest banks of the world, just like Bank of America, JP Morgan, Crédit Agricole, you name it. So all the top stars were ours. And there was a page that was the heart of the application. So it was the most important part where these orders were managed, and we could just decline some clients and reassign parts of the orders. So it had a very complicated logic. And there was one guy who developed this page 5 or 6 years ago, and he proudly said, so this page has 5 lines of code, and no one but me knows how it works. How do you think? Was this code stable? No, because if we had any release coming or anything, the first line of defense was to test this particular page, because most likely it had problems. Then the most important thing is every time you do something, ask yourself these 2 simple questions. Is what I'm doing fit for purpose? Does it add value? If the answer for any of this is no, change the thing that you are doing. So, how to fit better into continuous deployment? So yeah, you need to deliver in small chunks. Yes, that's true. Improvise, adapt, and overcome. So remember, I promised you to dig into writing more stable code. And one crucial thing that helps you here is ensuring that your code is tested properly. I think some of you heard about the testing pyramid. If you haven't, I can just explain you really briefly. So ideally, in the CI/CD pipeline, the code should be covered by 3 types of tests. The unit tests, most numerous, the fastest. Integration tests, slower, more complex, and less of them. And heavy end-to-end, automated, and the fewest. So let's start with the unit tests. The ultimate goal of unit tests is not to test functionality. The ultimate goal of the unit tests is to provide a safety net for your code when you make any changes. Whether you are fixing a bug or introducing a new functionality, your unit tests save you from errors. So the goal of the unit test is kind of regression. Do not break something that was working before. So useful, some mistakes and pitfalls of unit tests. Absence of unit tests or having incomplete unit tests. So if you don't have unit tests, it's okay. So it's okay to start writing them anytime because some unit tests is way better than no unit tests. Another big problem is red unit tests. So if the unit test is red, it means something is broken. It might be the unit test that is broken, because when you change your code, sometimes you need to change the unit test as well. Another thing is that unit tests are extremely large. Each unit test embraces too much functionality. So unit tests are granular. Unit tests are targeted on a particular small piece of functionality, a particular method, a particular class. So something very, very small. And it comes to the second one. Unit tests are more like integration tests, not testing in isolation. So the thing is that unit tests should be heavily stubbed, ideally completely stubbed, because the unit tests are called unit because they are supposed to test stuff in isolation without relying on anything. Another thing is that unit tests, as I already said, are not equal to functional tests because they serve different purposes. Yes, unit tests can cover a particular stuff that is referred to functionality, but do you know that you implemented this functionality completely right? Because the unit test checks that you've implemented the things the way you implemented them. But it doesn't mean that you implemented it right for the end user. Another thing is coverage doesn't mean the quality of unit tests. Because if you have bad unit tests, even if you have 100% coverage, I don't know on what scale, it means absolutely nothing. Your code is poorly covered. And if something breaks, your fully covered fully covering tests won't be able to detect it. Again, this also brings to the stage that you become overconfident when everything is covered by unit tests. Again, your unit tests may be as numerous as you want and as green as you want, but it doesn't mean that you implemented the things right. And another pitfall is that the unit tests take too long to run or have many external dependencies. What are the useful tips for unit tests? First of all, it's never too late to start writing unit tests. Every time that you type the code, ask yourself a question. Okay, we don't have any unit tests here. Will it add value if I write a unit test? Will it prevent some problem from happening? If I had the unit, even very simple, if I had a simple unit test here, would it prevent this bug from happening? Another thing is fix red unit tests immediately. Fix, not disable it. When writing unit tests, that's very crucial. Please listen attentively. So when writing unit tests, you should presume that everything else is working. Do not embed bugs in your unit tests. Then, again, when feasible, every time you fix a bug, you create a unit test for the fix. Again, when feasible, use common sense. Mock all the external dependencies in data. And please, 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 don't write unit tests, integration tests, automation tests, any tests, just for sake of having these tests. And if you learn about testing techniques, it will help you to write better tests. Now, integration tests. The goal of the integration tests, unlike unit tests, is to test the integration, is to test the interfaces between two parts, front end, back end, or two parts of functionalities or something. So they are not that much stuff because, again, it depends on the kind of integration you are doing. You can integrate top, bottom, bottom, top. You can integrate incrementally. And there is a way of integrating that I will never recommend you, and I will talk about a bit later. But integration, again, the goal of integration, not to test the functionality. The goal of integration is to test how the interfaces talk to each other and find the problems in the interfaces. the thing is that two pieces of functionality can work perfectly well in isolation, but when you marry them, you have the problem. So what are mistakes and pitfalls of integration testing? Intergroup tests, because it's kind of, it's always a struggle, I know. It's always, you need to find this balance, but again, try to keep them separate. Well, in our case, on our particular project, unfortunately, we don't have any integration tests because of certain limitations. We rely on our automation to do the integration test, end to end. It's not good. It's not ideal, but due to some limitations, that's what it is. But it doesn't mean that we don't need them. We are implementing them in a bit different way. And the worst thing that can happen with your integration is the Big Bang. So Big Bang means when you are integrating everything in one go. And it just ends up usually in a disaster. When you are integrating bit by bit, so okay, you integrated A and B, it worked fine, but when you integrated C, everything just fell apart. It means that there was something wrong, something bad happened when you integrated C. So you can take a look, you can identify what changed caused the problem. But when you're integrating in Big Bang, means that you're putting everything together, it's really hard to track what caused the issue. And I worked on a project where the integration was done in a Big Bang, and I would say that this project was delayed for a year. So do not do Big Bang integration. What are the success factors for the integration tests? You need to know the initial state of the system. So your system should be in some certain state. Don't rely on shared resources and data. Always prepare your own data and create a reliable source of data. It's really funny because just today, well, in the morning, we had a huge conversation how to streamline managing the test data for different level of tests, well, company-wide. That was a very interesting discussion. And automation. Test automation is a big topic that I can talk for hours. For me, the test automation is the next level of development because you're writing the code that tests the code. The test must be stable and reliable, way more stable and reliable than code itself. Also, they should be fit for purpose and doing the right thing, not simply exist. And the best automation tests that I have ever seen were a team effort between testers and QAs, testers, QAs, and developers. And that's exactly what happened in my team. We work together with developers to deliver really good and stable tests. I provide the perspective to make sure that we are doing the right thing, we're covering the right thing, and they help me to write the code in the right way. And please remember about performance. Because performance can be tested almost on any level. And yeah, it's very important to understand how your application is performed. And please, please, please test manually at least the most crucial thing, the happy path, because the happy path is always more important than the negative path. You need to make sure that if your application is used as intended, it doesn't break. And you need to improve your skills. How to improve your skills? You need to face a challenge to become better. You need to constantly evolve to keep up with the ever-changing world around. So if your team delivers software as a service, it would be beneficial to understand how it works, how to deal with high availability, to provide the appropriate solution for this high availability. So just for example, if your software is running 24 hours, 7 days a week, 365 days a year, it means that you can't afford the luxury of memory leaks, right? And another thing that many SIS struggle with is being user-friendly. You need to be more careful with database migration upgrade. Say for a cluster solution, how do you introduce a database change, like adding a new table or deleting a new one? The solution is, first, okay, you are deleting an old table, right? again, remember, we need to deliver in small chunks. So you need to update the code slowly that can work without this table, without using this table. First of all, you need to make sure that this code is sitting on all the servers that are using the database. And when you make sure that no servers are using this particular table, then you delete it. And again, you make sure that whether your table is in or if it's not in, your code can cope. So backward and forward compatibility is very important here. Again, compatibility. It's another huge challenge that you need to understand when you are developing your code. Whether we are talking about compatibility of the software, different kinds of software, front end, the back end, because sometimes they are developed by different teams, or compatibility between microservices. So how your microservice will be working with another microservice that another team is developing, or how compatible your software is with third-party software that you need to integrate with. Another big challenge is security. Please, 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 please remember the security basics when you're developing your code. Like making sure there is absolutely no way to make an SQL injection into your code. Please refer to OWASP Top 10 security vulnerabilities, for example. I will send a link to this as well. Think about compliance. Compliance to different rules and regulations is a particularly challenging topic when we are talking about continuous deployment. You still can be compliant with, say, FDA or ISO 9000 when running CD. That requires additional effort. It requires deep understanding what are the rules and how you can fit into the rules. But if you can't do this, if you can't meet the regulations, you need to know it sooner rather than later. And you need to continuously improve. How? Well, appreciate the bug reports. They're really good for keeping tracks for the problems, even if you aren't going to keep them. So the next time, if anyone comes with the same question, they can find a ticket in Jira or what bug tracker Mindshift, whatever you're using, and see a solution. Okay, we won't fix it because of this and this. By the way, the bug that you see on the picture is a real bug. It lives in New Zealand. It's called a giant weta. So it's kind of a cricket. It's absolutely harmless, just ugly. And so when you're creating or somebody is creating bug report, you need to make sure that this is a good bug report. First of all, you need to write, the bugs must be reproducible. So you need to write the bugs, or somebody needs to create bugs in such a way that anyone can reproduce it. And please don't waste explain to someone who creates a bug not to waste time on creating unnecessary bugs. So usually when I find something, I come to my developers and say, hey, look, I see this problem. And I can tell, no, that's as expected because of this and this, for example, see the requirements. Or we just made this decision, see this document. I'm fine. In this case, sometimes I just don't do anything, or I make a note to the user story that we are aware of the situation. But if they say, yeah, that's a bug, I log it in, even if we don't deal with it. So people could just ask, people who later ask the same question shouldn't bother anyone else. So, yeah. And you need to know your domain. Knowing your domain will allow you to better understand what the problem is that you need to solve and what value it brings to the customers. Use the reviews. Reviews are a very powerful tool. And so they help you to find the incorrect technical approach, or that you're not following the coding standards, which mean that your code is poorly readable. And this means that it's less maintainable. And another thing is that if your code is reviewed by someone before it reaches the production, it's kind of a gateway that helps you to find the bug before it reaches the production. So reviews are a really cool thing that you need to use, but a very crucial thing about reviews to remember is that they should be done in the atmosphere of trust. And the problems that you find there are actually a good thing because we didn't ship it to production. And about mistakes, anyone can make mistakes and anyone can make a very simple, stupid mistake, well, just because we are bloody humans. So, useful tip for reviews. Try to avoid submitting large pull requests because it's very hard to review them. I was guilty of this. Set the right review objectives because, for example, you have a raw. That's what happened to me as well. I have a raw code and I just want someone to check if I'm using the right approach. So reviews can have different targets. Do the review thoroughly. Make notes. Please make notes. Well, actually, when you're doing a review, say we are doing this in Git, it's very easy because you're adding comments. But if you don't have this tool, please write down the comments and always follow up, fix the stuff, and learn from reviews. Diversify your knowledge, which means don't limit yourself just to being a front end or back end tester or developer. So try to learn a bit of both so you could just develop better, and in a case of emergency, you can just fix something. And of course, develop yourself as a developer. Learn new languages, learn new technologies, just keep improving. And boost your luck. So improve your critical thinking. Question everything. And ask, well, now I will discover you the main power of testers. The main power of testers is the art of asking the right questions. And the most powerful question of all is what if? What if I do this? What if I do that? Another important thing is expand your expertise by working with various teams on various projects using different technologies, different domains. Expose yourself to new experiences. Don't limit yourself just to developing one functionality for 10 years. And learn new things. You can learn from anyone and everyone. Just don't forget to question what you've learned. You can learn from product owners, support, but the most value you can learn from testers. Because if you know how testers develop their tests, you can write better unit integration automated tests and test your code yourself, especially if your team has no testers. Learn from DevOps. This will allow you to make the right decisions about the architecture of your software and its maintenance on a larger scale. Use the best practices. For example, pair programming for complicated tasks. Because there are two huge benefits of pair programming. The first benefit, the most important benefit, is shared ownership of the code. And B is that two pairs of the eyes look at the code and you kind of get an instant view and you just think together. And when you talk to someone, when you're trying to explain something to someone, you better understand what you want to deliver. But do not abuse pair programming because it's a very, very, very effort-consuming thing. You can also try TDD. And it doesn't necessarily mean that you need to do TDD at full, so develop a test, write any code, then refactor, and blah, blah, blah. No, just really thinking, before writing the code, thinking of what scenarios could happen, allow you to create a better code. To be even better, if you create some unit tests before the code, it will help you to kind of think, oh, okay, I know that I will test with this, so how I create my code better. And that's exactly what we recently used on one of our projects, so I suggested this. We used it, and it was a roaring success because we had really few bugs, because we covered many scenarios in unit tests before the actual thing happened. And learn soft skills. Because once I wrote an article about the soft skills, because I've been on many meetups with testers, and when we collected the feedback about the problems the testers face, about 80% of all the problems were about miscommunication, soft skills, and stuff. So just put some effort into developing your soft skills. It will help you not only in your day-to-day communications, it will always help you to boost your career. And use your most powerful weapon, your brain. Another critical ability that you need to develop is to learn to make decisions having incomplete data. The pace of continuous deployment is so fast that there will never be complete data. By the time the data are complete, they are already obsolete. Learn troubleshooting to identify the root cause of the problem and to fix it quickly. So I will give you a link to a very, very nice course on Pluralsight on basics of troubleshooting. I think it will be really helpful for you. And also learn about lean principles, like optimize the whole, build quality in, eliminate waste, create knowledge, deliver fast, defer commitment, and respect people, most and foremost. So yeah, now let's recall what we learned so far. First, the old way of testing no longer works. Deployment is a new reality we need to adapt to and adapt quickly. It has a completely different process and requires a different approach to everything, especially to development. To do this, we need to be more effective than we used to, so we can fit into the new environment and thrive there. And there is another video that I wanted to show you. So, what it takes to be successful in something. I have selected the main picture of this presentation, the launch of Falcon Heavy, on purpose. So that's a video of the launch created by the Verge team. The very existence of the SpaceX project required a paradigm shift. That a single private company can do better than the huge government-sponsored NASA agency. It was a paradigm shift that you can land the launching rockets and reuse them. It was a paradigm shift that you can deliver cargo into space 10 times cheaper just within several years. Was this particular launch a success? Well, the main unit didn't land. The Tesla Roadster is not heading to Mars as planned by the asteroid belt. But what is most spectacular about the SpaceX project is that they didn't give up. They are not afraid to take a risk, which larger companies don't dare, and they continuously learn from their successes and from their mistakes. So don't be afraid to take a risk and change your world. Remember the wise words of Sir Winston Churchill. Success is not final. The failure is not fatal. It's the courage to continue that counts. Please keep trying. Thank you. That is all.
Thank you.
Thank you. Thank you. It's awesome.
So just like within the next 5 minutes, I will send, after we finish, I will send Jeff the links that I promised. And if you have any question, anything, just feel free to ask. So I'll be happy to help. So if you need some advice on how do I learn about some testing stuff that I can use in my work or anything, or if you have a particular question about CI/CD that I can help with, just feel free to ask.
How big of a team is too big? I mean, if everyone has the ability to commit to production, doesn't it get scary the more people you add into your development team?
Well, no, because I can say that in our team, well, because we kind of overseeing 2 teams, because if you build the process right, it's not scary at all. So we recently had 2 interns, but the interview process in Bend makes sure that you really get the best people, both for the skills and the culture. That's A. And B, again, our intern in our team, she put the first commit in production, fixing a bug, in about 2 days after being with the company. And we were not scared at all. Because by this time, first of all, her code was reviewed, right? So we have a stable review process. So if there were some problems, if there were some flaws, then the reviewer would catch him. Because again, another thing for CI/CD pipeline of CI/CD process that it requires best professionals ever. So everyone is highly skilled. And people who come in the company, they either become highly skilled very quickly or they leave the company. So no, it's not scary. Because again, we know that if anything screws up, we can quickly fix it. Now we have around, well, more than 50 developers, not a problem.
Huh.
Maybe more. I'm very bad with numbers, sorry.
So how do
should
you?
have-
Oh,
Sorry.
Go ahead.
Yeah, go for it.
So I'm just curious how you handle, you know, if there's no rollbacks, like how you handle instantiation of applications. So, you know, I make a change, it accidentally, I don't know, deletes one of the instances of the database, and then the other server in the cluster fails or something. You know, like what about things that, you know, you have your database, for example, set, you know, in a different. I'm not explaining this very well.
No, I see what you mean, but again, even if you were able to roll back stuff, rolling back a database state is a problem. So the first thing that you need to learn to do in continuous deployment is to deploy in small chunks that won't cause these drastic things. And again, in our team, so in the project that I'm currently working on, we have the rollbacks. But in some of the projects that I previously worked on, and on the project that my husband works on, they had no rollbacks because the structure was so complex that it was faster either to turn the feature flag off or on or deliver the fix.
I had
Yep.
a question about the feature flag. So when you set it to a certain percentage, it's just going out to a random percentage. I'm sorry. It goes to a number of people randomly as long as they're like 5% or whatever your cutoff is. Is that right?
So it depends on the particular feature flag system that you're using, because we have our own homebrewed software to do the feature flags, and our does 500% absolutely randomly, which is not ideal because it can go to the wrong 5% people. But that's how we implemented ages ago. So I included into my list some links to different kinds of feature flag software. So maybe these guys have different answers. In our case, it's completely random, which is not ideal, but that's how we roll. Any more
Okay,
questions?
so can you hear me?
Yep.
No? Okay, cool. So at Vend doing QA, are you more writing like acceptance tests, like writing tests that are running through the suite from like a staging environment?
So in our case, we don't have a staging environment, unfortunately. I'm working towards this, but we test on either locally or we test in production. So actually it depends on the project. Yeah. Well, yeah. It depends on the project. So right now we are developing a new feature, and what I will be doing, the guys have created the user stories. I participated initially when they were splitting into the big chunks. And now I will work together with the team to create acceptance criteria for the user stories. After that, I will just sit and think how I'm going to test all this stuff. Maybe I will create a decision table. I will just write down some test scenarios, and I will consider whether I need to add some automation to this, or I just continue working on testing some other stuff, or I just should continue testing the reworking the automation, because right now I have a task to make our automation tests environment agnostic. So again, it depends on the project. Because when we had a big thing coming, so the big thing was when we completely reworked how our main page was doing the calculations. It means that we put a lot of effort into thinking how we are going to test. We were sitting with developers, we developed a huge decision table. It's one of the approaches to testing, how to develop test cases. I don't say that we implemented and tested every single scenario out of this decision table, but the very idea of developing this decision table helped us to think in the right direction and to make sure that we cover the most crucial areas. Did I answer your question, Jeff?
Yeah. So, how many QA engineers do you have at Vent?
5 at the moment.
And how many core services do you have?
Oh, well, many. So actually, the thing is that each team is responsible for several core services. So we have five testers. I cover 2 teams. We have another team another 2 teams that do development, but they have no testers. They code by themselves, and we just consult them if needed. And we also have DevOps and infrastructure teams that they don't have testers. They just do whatever they do by themselves. Oh, we have a data team. With data team we collaborate, but again, so we have way few QAs than even than the teams, and that's why the QA resource becomes very valuable.
So how many, if you're one QA person matched up with multiple teams, how many projects are you actually sort of writing tests and doing QA on?
So currently I have on my plate 3 projects, 2 in one team and 1 on another. But the other team is kind of in the early stages of the project, so I don't participate there that much. And it allows me to manage better what I have. So it's okay. I can manage this. But yeah, I'm managing 3 projects at the moment because in our team we run into projects in parallel.
Can you talk about the platform or technologies you're using for your CI/CD pipeline, or is it home rolled by your infra team? We are using Docker. We are using Jenkins. So the idea is that we deploy our products in Docker images. So ideally, the Docker image that you have on your test environment, on your dev environment, in your any environment, is pretty much the same what you ship to production. Well, in theory, in reality, it's a bit different, but still, it's pretty close. And sometimes for some tasks, so we used to use Travis before, and we still have Travis for some of the projects historically. We are slowly moving into Jenkins. But it's a trade-off because both Travis and Jenkins have their cons and pros. So, yeah. What do you think about configuration as code?
It's a good thing. It's a good thing. It's just like I think it's a new trend that will be really helpful because it's just like. I think it's another paradigm shift as when treat your servers like cattle, not pets. That was the first paradigm shift, and that's the second one because it's really convenient, right? Because you just like create a script and it creates an environment for you. So it's just like that's awesome.
What are the core services written in for Vent?
Oh, historically it's PHP. Don't laugh, because one,
Our founder created the core of and the monolith almost by himself in PHP, and it was a huge thing. And you know how the legacy code works. But now we're trying to kind of pick up or just put the chunks into smaller services. And now we have a rule that all the new services are developed in Go. So front end is we trying to move from, so historically it was JavaScript, but now we are moving to TypeScript. And for backend, we use Go.
Are you running native TypeScript then, or are you guys using another framework with TypeScript?
Native, I think. Yeah, native. We don't use any framework or anything. And because I forgot to mention that I'm writing my automation in Cypress, and I have another separate presentation in Cypress. It's in the asynchronous automation testing tool for the user interface, and it supports only JavaScript or TypeScript. And for testing, TypeScript is a bit better because it still allows you to shoot yourself in the leg. But just with JavaScript, you will most certainly shoot yourself in the leg, and TypeScript just reduces this probability a bit. So I like TypeScript more. And now we're thinking that we want to shift our part completely to TypeScript.
Any last questions? All right, well, thanks for your time, Kat. This has been awesome.
Oh, you're welcome. Mostly welcome. Thank you for listening to me.
Thank you, Joe.
Thank you.
Bye. Thanks a lot.
Any last words, Jeff? Anyone else?
Couple of times.
Now it's casual. You can just talk. I know we're recording it.
We're still recording.
No, I think we're good on our end. Thanks, Arsh.
Awesome.
The recording has stopped.
All right, now if anybody wants to say anything. All right, bye, Juno. Bye, Fairbanks.